Last time we were talking about our place in the solar system, and we concentrated mostly on the sun, earth, moon coordinates, and we talked about different eclipses and stuff like that. And then we started zooming out a little bit and we started talking about the earth going around the sun. So we're going to continue that and we're going to talk a little bit about stars and we're going to talk a little bit about planets. All right. But first, what we're going to have to do is sort of because we're zooming out so much, we can't keep showing Earth and all of these labels and stuff like that. So we're going to simplify things a little bit, which hopefully you'll be able to follow along with relatively easily. But let's go through some of the simplifications. So we have this coordinate system where we basically have the sun at the center and we have the Earth going around the sun. And different seasons are represented by that. So at the bottom, we have vernal equinox, which is March. We have northern summer, which is June. Then 3 months later, we have autumnal equinox, which is September. And then 3 months later after that, we have December, which is northern winter. 3 months after that, we come back to vernal equinox, which is March. So we're going to abbreviate those. I'm going to call it vernal equinox, VE. Northern summer is NS. Autumnal equinox is AE. Northern winter as NW. And basically, we're just sort of representing that there are 4 seasons on Earth and we're just moving throughout a year. That's all we're really trying to represent. Now, we need to talk once again about midnight because a lot of this stuff is like, when can we see stars and everything? If it's not cloudy, we see one star during the day, and that's our sun, right? We can't see other stars during the day because the sky is so bright and everything. But at night, we can see stars. Midnight is our reference. Midnight is pointed away from the sun. So if we're on the night side of the Earth at midnight, we will be able to see stars and planets and stuff. And that direction of midnight changes throughout the year. And that's sort of the whole point of this lecture. We want to make sure that you understand midnight points away from the sun all the time. And so what we're going to use is this coordinate system where we have vernal equinox, we have northern summer, autumnal equinox, northern winter, and midnight is always away from the sun. I personally am not like a huge constellation person, but if you are a big constellation fan, you'll probably know that you can only see certain constellations in certain parts of the year. Now, the reason for that is because stars are in different directions away from our sun. So if you wanted to see Leo from northern winter all the way through vernal equinox to northern summer, but it would change what time you could actually see it. So it would go from dawn, being able to see it in northern winter, to midnight, being able to see it in vernal equinox, to dusk at northern summer. And then you could change this around for all of the different constellations. You see them throughout different times of the year, throughout different times of the day. But there are times of the year where you absolutely cannot see them because the sun is in the way. So like for Cygnus, it's the same thing. You can see it from vernal equinox to autumnal equinox, and it goes from dawn to midnight to dusk throughout those seasons. Now, interestingly, you can actually measure how far stars are from us based on this whole thing. So how do you do that? Well, we can see Orion, for example, during different times of the year. So we see Orion at dawn during autumnal equinox, at dusk during vernal equinox. The distance between autumnal equinox in the sun and vernal equinox in the sun is the same, but from vernal equinox all the way up to autumnal equinox, that distance is about 2 times the distance from the Earth to the sun, right? So that is a very long, what's called baseline, all right? And we can then use geometry to figure this out. We make this triangle, and we know Orion is far away in this direction over here. And so we measure these angles, and we can measure these angles throughout the entire year, and we can draw this triangle. And we know the distance from the autumnal equinox to the sun and vernal equinox to the sun. And we know the angles that we're measuring. And so doing some trigonometry, we can calculate the distance between the sun and Orion. So now let us look at planets. All right. We want to say, understand when we can see Mars. All right. Because Mars is different than a star because a star is relatively fixed. Okay. Our star is relatively fixed in orientation with other stars on human lifetime scales, at least, right? But Mars actually moves around the sun, okay? And that complicates things. So let's pretend that Mars is sitting in a line with Earth during vernal equinox. So we can see Mars at midnight. The sun is shining directly on it, it lights up. But if we go 6 months later, we are on the other side of the sun. We've changed from vernal equinox to autumnal equinox now. It's from March to September. Mars, on the other hand, has only gone about 90 degrees in its rotation around the sun because it takes about 2 years to go completely around the sun. And so now you can see that it's a very different orientation. And we see it during dusk now. We used to see it at midnight during vernal equinox, but now we see it at dusk. If we go another 6 months back to vernal equinox, now Mars is on the other side of the sun from us because it is only halfway around the sun. We've gone one complete turn around the sun. One whole year has gone by. Now Mars is on the other side of the sun. We can't see it at all, right? It's completely gone. We can't see it at all. We go another 6 months and Mars shows up at dawn now. We're back at autumnal equinox. And then Mars is 3/4 of the way around the sun. And then if we go to a full 2 years, we're back at vernal equinox. And Mars is now aligned in this position. And so we see Mars at midnight again. And this works really well because a Martian year is 2 years and an Earth year is 1 year. So every 2 years we get this pattern that shows up. It's further away from the sun, so we can see it in the night sky. We can see it at midnight very easily. Every 2 years we see it at midnight. So planets further out, if we generalize this, and we talk about Jupiter, Saturn, Uranus, Neptune, and, well, we put Pluto in parentheses because people don't consider it a planet anymore, but it's a planet in our hearts. Jupiter takes about 5 years to go around the sun. Pluto takes like 220 years to go around the sun. And so their motion around the sun is different than the Earth's motion around the sun. And so that determines where we'll see it. And none of them beat the same way that Mars beats. And so it's not like a fixed time step. We see, Jupiter at the same time at midnight in the same season every 5 years or something. It doesn't work quite that way. We do see it at midnight fairly often, and that season that we see it at midnight changes throughout the years. Now, let's look at planets closer to the sun. Venus is one such planet. We are at vernal equinox, and Venus is between Earth and the sun. We definitely wouldn't be able to see it at either vernal equinox or autumnal equinox, but we could see it at northern winter or northern summer, but either at dawn or at dusk. It's still going to be sort of light out, though. So at t equals 0, you can't see Venus at all because it is between the Earth and the sun. But if we go 3 months later, Venus has actually gone a significant distance around the sun because its year is much shorter than our year. We've gone about 90 degrees around, and we can now see it at dawn. About 3 months after that, or 6 months, we continue to see it at dawn, but you can see that it's a bit of a shallower angle, so it's probably visible only during the bright part of dawn. Then when we go 3 months after that, it's now at such a sharp angle, it's only in the sky near noon, and so we can't really see it anymore. And then 3 months after that, it is on the other side of the sun, and so we can't see it again. So Venus can't be seen high in the sky at night at all because it doesn't ever go on the night side of the Earth. You can only see it at dawn and dusk. And interestingly, during one year, you can see it at dawn. During the next year, you see it at dusk. And then the next year, you see it at dawn. Next year, you see it at dusk. Venus' year is about 7.5 months, so the cycle doesn't repeat exactly, but in general terms, this is what happens. Okay, Mercury is even closer, and so it's even harder to see throughout the year. And so you see it less because it makes a steeper angle towards the sun. So it's hard to actually see Mercury. Because it's even closer to the sun, you never see it at midnight. You can't see it actually at night hardly at all. You only see it at dawn and dusk. And we mostly see it during the day when it is bright enough. All right. So if the sun is down, is close to the horizon or something, and the sky is starting to dim, then you can start to see Mercury. But it will always be near dawn or dusk. You can calculate distances to planets exactly the same way that we did using the method to calculate the distance to a star. We use the same thing. We have the sun-Earth distance, we know that. We know the angle to the planets at different times of the year. We can measure all of that stuff, and therefore we can compute the distances. And we've been doing this for a very, very, very long time. Kepler did this back in like 1600 with his telescope, and he discovered that Mars doesn't make a perfect circle around the sun, and he was very confused by this, and that's why he actually came up with his 3 laws, and he did it exactly using this calculation. You get angles, you have distances, you do some geometry, and you can calculate the sun-planet distance very easily. Okay, so summarizing, stars remain fixed in our field of view. The seasons determine when we can see them. We can't see them during the day, so we only see them at night. So it's only when the night side is facing those different constellations that we can actually see them. We see them at the same times of the year, every single year. Planets further away, the seasons determine when we see them because the planets move around the sun. But because the planets move around the sun, that cycle can change. We can see them at midnight. We can see planets further away at midnight. But planets closer to the sun, we view them mostly at dusk or dawn, which changes depending on the location of the planet. And we can't see them at midnight at all. We can use geometry to determine distances. And it's the same exact type of geometry for planets as it is for stars. We use angles, and we know the sun-Earth distance, so we can calculate all of these distances. And that's what we've been doing for hundreds of years.